Find f of x for x equals 3.5. In this problem, the degree of fulfillment for the premise clauses and arguments for the fuzzy consequences are provided for rules 1 and 2. The problem states to use the norm-weighted sum combination method to develop the function f of x, where f of x equals the sum of the degree of fulfillment from the premise clauses, vi, times the membership function of the fuzzy consequence, beta I times mu bi of x, where beta I equals the influence factor and mu bi of x equals the degree to which the fuzzy consequence is fulfilled for all rules I. The problem statement provides the premise degrees of fulfillment for both rules. For each rule I, the influence factor is inversely proportional to the area beneath the fuzzy consequence. For rule 1, area B1 equals 1/2 times 1 times 4, which equals 2. Therefore, beta 1 equals 0.5. The influence factor beta 2 is computed by multiplying 1/2 times 1 times 2, which equals 1. Therefore, beta 2 equals 1. The degree of fulfillment of each consequence, mu bi of x, varies with x, and needs to be evaluated for each slope change of any fuzzy consequence. This means f of x will need to be evaluated for 4 separate ranges: 0 to 2, 2 to 3, 3 to 4, and 4 to 5. Evaluating the first range, where x is at least 0 and at most 2, the degrees of fulfillment and influence factors are plugged into the equation, and f of x for this range equals 0.1 times x. This calculation is repeated for the second range, where x is at least 2 and at most 3. The values are again plugged into the equation, and f of x for this range equals 0.4 minus 0.1 times x. When x is at least 3 and at most 4, f of x equals negative 1.1 plus 0.4 times x. And when x is at least 4 and at most 5, f of x equals 2.5 minus 0.5 times x. If we expand the table to include a column for f of x for each range, we can plot the function f of x for all 4 ranges. The problem asks to solve for f of x when x equals 3.5. Therefore, 3.5 is plugged into the equation for range 3, and the final answer is 0.3. When reviewing the possible answers, the answer is C. To develop a fuzzy argument, mu of x, from rules 1 and 2, using the normed-weighted sum combination, f of x is divided by the maximum value of f of x, so that the maximum value of mu of x equals 1. From this problem, mu of x equals twice the value of f of x, since the maximum value of f of x is 0.5.